For today, I prepared a 20mm thick steel plate and some 15mm thick cold-drawn flat bars. We are going to dive into making the ATC turret head for my CNC lathe. I prepared the 3D model of it in ZW3D. If you followed along with my videos, you probably saw it already. To begin the whole process, we will start it off today with making the body, aka the housing. I made some drawings of the parts. And let's the fun begin. The stock is the material you saw just before. First, as usual, I'm taking the stock to the right dimensions. First reference wall done. And now all reference walls are finished. Let's proceed with drilling. Dialed in, and the rest of the holes can be done. Chamfers, always welcome. Now the counterbores, all to make it cozy for the bolt heads. The base plate seems ready-ish for now. Of course, not without some little mistakes, as always. Now, for the sidewalls of the whole body, gonna use these 15mm thick cold-drawn flat bars. These two pieces have to split into 4. Let's take a look where we are right now. In the middle of nowhere. Same history. First milling it to size. Straighty. Now it already feels much better. Oh, by the way, the brand Thermal Master sent me recently a thermal camera, in case I had suddenly any thermal issues with my machines. It's the Thermal Master P3 with a USB Type-C port, which can be plugged in into a smartphone. It's got a manual focusing ring in front of it. I had some little issues with one of my contactors in my new CNC lathe which I'm building, so I thought I could give it a try and check my machines if there's anything suspicious going on. Oh, hence temperature seems about right. The first thing I noticed, it doesn't work very well with reflective surfaces, probably due to their low emissivity. Inside the cabinet, however, we can clearly see spots which generate higher temperatures. The machine has been turned on for a while, nothing wrong going on here. The servo drivers seems coldish. Spots with higher temperature are visible though. For example, the breakout board. Some of the inputs which are working right now are warmer than other regions of it. Same with the CNC controller. Fun fact, we can see the AC input wires are colder than the DC output wires. There is current difference, due to which we see the difference in temperature. In the second control cabinet, there are contactors which were suspicious for some issues I had recently. I like how the cables glow. These are supplying power to the whole machine. Sadly, I can't see anything wrong here right now. Same with the third contactor. What can be useful for troubleshooting, I can clearly see which relay is now, or recently was, turned on. I just turned one relay on the panel, and after a moment it starts to warm up a little bit. Oh yeah, and there are the servo motors, the spindle drive, and the Z-axis servo motor. Nothing wrong here as well. And the working proximity sensor is also a bit over the ambient temperature. Let's see the heat of machining. The thermal camera seems not to be a perfect idea for reflective surfaces, but there is a visible heat coming from the machining process. Cranking up the cutting speed makes the machined part heat up more. I managed even to try out the safety feature which shuts down and protects the camera from being damaged. After some tries on the lathe, we can clearly see which relays have been working recently in the electrical cabinet. Same with the wires, the temperature raised a bit, as the machine was drawing more power out of the outlet. The electronics seems fine though. No overheating in there. I checked with this camera also my CNC mill. The machine is turned on for a while, but the servo drivers don't overheat anyway. Also here, the warmest spot seems to be the inputs of the breakout board. Whoa! And the coil of the fan motor seems to be quite hot. The VFD, however, is cool. The relays were not used recently, but after an hour of working on the machine, the used relays are warm too. The motors on my mill are not hot at all. The light seems to be the warmest part of the machine. That's what I like to see. Being honest with you, I think this little device might be helpful in a machine workshop. Many machine failures manifest their presence with unexpected heat. For example, damaged or badly assembled bearings, damaged electronics, overloaded motors or drivers. A thermal camera might help to find such faults and fix them. If you think such camera would help you with your projects, you might want to take a look in the description. I added a link for more details. There is also a discount for my viewers. And now, as we made sure our machines are ready for work, let's proceed with our job. Next one, the centers of the holes. The holes are drilling them by themselves. Nothing fancy here. The machine is working on its own. I mean, it's a CNC. Things are getting serious now. There enters the end mill. I'm going to install a steel bushing in there. I made this toolpath using ZW3D CAM module. This is our product. The rest of the sheet goes to the trash. Nah, I'm just kidding. Counterbores, once again today. This plate looks promising. There is also the second plate, which is similar but not exactly the same. I'm going to mill out a pocket here. A cable gland will fit in right there. Oh, fits fine. Let's head on to the topping. These threads will be used to mount the air cylinder for unlocking the locking mechanism of the ATC. Quick test fit to avoid diving into mistakes too deeply, seems fine. Now I'm going to prepare these plates to bore the bushing holes in one aligned axis. Finished hole should be perfectly aligned. More holes? Never enough. Front and back plate are finished. Sidewalls remaining. And in meanwhile, the top cover. Will be nice to have it later on. I would tell you here a drilling joke, but fire in the hole. The other parts are not ready yet, but let's make a test fit to check if everything is at least about right. Well, today's adventure has come to the end. But there is still a lot of things to do. The body is kind of finished. In the next part of the CNC lathe build, however, we are going to deal with the internal parts of the ATC turret. There will be a lot of machining. On this lathe, the machine will be already producing parts for itself. Oh, and a kind reminder, if anybody found the thermal camera I was using today useful, don't forget to check the link in the description with the discount code. And thanks for watching.